Good morning. Welcome to another edition of Kung Fu Physics. I've got another easy mechanics problem off of the practice physics GRE exams for you today. It's number 4 off of the 2001 exam. It's short, it's easy, well, pretty short, I guess. Let's go ahead and just do it. So the answers are 0 or some fractions. I just glance at those and then move into the problem. Number 4. In a non-relativistic one-dimensional collision, a particle of mass 2m collides with a particle of mass m at rest. If the particles stick together after the collision, which fraction of the initial kinetic energy is lost in the collision? Now, when I do problems like this is a great example of one that I can keep really simple in my head. And literally, I will kind of think along these lines. I will look at the initial conditions before the impact and the final conditions after the impact, and look at and analyze whatever I can from there. Literally, I mean, I'll even draw a picture sometimes. So, what do they describe? A 2m coming in here. And that's coming in with, I'm going to call it a velocity v and particle m, and then the final, they've stuck together, so they are now a mass 3m moving with some velocity v prime. Right. So it's asking us about kinetic energy. The kinetic energy initial of this is all tied up here, so it's 1/2 2m times v squared. The kinetic energy final is going to be 1/2 times 3m times v prime squared. Right, but I don't know what v prime is at this point, so I can't get the ratio, or I can't get the kinetic energy lost or anything like that if I don't know what v prime is. So to get v prime, I'm going to look at the momentum. So here I'm looking at energy. To get v prime, I'm going to be looking at momentum. And if you've looked at some of the other problems I've done, it's important to realize that in a collision like this, where things are sticking together, energy is not conserved. It's obviously not an elastic collision, so energy is not conserved, but momentum is. Momentum is conserved. So all the momentum here is just mass times velocity, right? So 2m times v. And then the final momentum is going to be 3m times v prime. And I'm setting those equal to each other. So I'm going to erase my line there. I have 2m times v equals 3m times v prime. The m's, of course, cancel, and very quickly I can solve for v prime. It's just 2v over 3. So what I want to do there is plug this in here for v prime. I'm going to move it down here. All right. So 1/2 times 3m times v prime squared. And so I'm not even going to write that out. I'm going to try and save myself a step here. And 4/9 v squared. Okay, and then I'm setting these two equal to each other. Okay, just for the sake of being clear, I'm going to erase this and move that down there, just so it's not a total train wreck here. And we'll look at how that works out here. So, what? No, I'm sorry. I'm not going to set those equal to each other. I totally misspoke there. What I want to do is compare them. I want to compare them. But first I should, so this is my kinetic energy final, and I should just simplify this. So I'm just going to simplify this. This is going to be 2/3 v squared, right? mv squared. Huh? Did you do that right? Yeah, I did that right. It's 2/3 mv squared, and this is just mv squared. And these I am comparing. I'm not setting equal to each other because, as I said, energy is not conserved, but I'm comparing those two. So this is my kinetic energy initial of magnitude mv squared. This is my kinetic energy final of magnitude 2/3 mv squared, right? Now the question asks, you have to be very careful to answer correctly. The question asks, what fraction of the initial kinetic energy is lost in the collision? So here we've got 2/3 of it left, remains. So how much was lost? 1/3. 1/3 mv squared is the magnitude of the kinetic energy that was lost as friction and sound and whatever else happens in a collision like that. So 1/3 mv squared, well, the fraction would just be 1/3, I guess. And so when we look at the answers, we have one of those, and that's answer C that we want. Notice that answer E is that sucker answer. If you got overly excited and said, oh, 2/3, it's in the answers, and answered quickly, you would get it wrong. So it doesn't hurt. It doesn't hurt if right before you actually circle your answer, you reread to yourself exactly what they're asking. You know, it's a moment, an extra moment there, but if that helps you from even misanswering one problem and losing the points for one problem that you would have otherwise gotten right, it's worth it, right? So answer carefully. It's answer C on number 4 off of the 2001 exam. As always, thanks for watching. See you next time.